Hey everyone, welcome back to Bytesector. It's been a while since we published our last review. Today we're going to dive into a discussion about AI, artificial intelligence. To many, it's this future dream concept scenario, a utopia almost. The truth though lies a little closer to home, in that it's our everyday present reality. AI is everywhere. We find it in our self-driving cars, real-time language translation, image classification, object recognition. We find it in things like Netflix, information technology, information security, robotics, our cell phones for gosh sakes, and even apps like Instagram or Snapchat. AI is everywhere in 2019. The common perception around AI is that it's complicated, expensive, complex, not for ordinary folk like you and I to think about or even worry about. To some though, it's a daunting and scary prospect for humanity's future. Visionaries have come out and said we shouldn't trust our lives to AI and that we should approach AI with some caution and temper our enthusiasm to put it everywhere in society. And yet, every day, we all click allow or I agree or I accept when an app or an application on our computer says, hey, I need access to your phone logs, your text messages, your photos. We're all guilty of it, and yet we all do it daily without thinking. Popular apps like FaceApp that recently came out and got so much popularity, nobody thinks about that. Nobody wonders what is that application's actual purpose. And I'll be honest, I can't say with 100% authority what its purpose is, but I can guess that it's to gather face information to train an AI model and improve that model's accuracy. Artificial intelligence. It's a bit of a misnomer in society. I mean, I've worked in IT for decades, and more recently, you hear terms being thrown around the industry like AI or machine learning or deep learning. And you know what? If you don't come across somebody who actually knows what those terms are, they're used interchangeably, almost synonymous for each other. The reality, though, is very different. So let's figure out what these three terms are, what they mean, and why we have to talk about this before we talk about our product today. Artificial intelligence, AI. It's an overarching term to refer to systems that are capable of performing operations without much input, able to learn, able to infer, a whole bunch of things. It's kind of the top layer, if you will. Now, below that sits ML, or machine learning. And machine learning is where things start to get interesting, because at the AI level, we've seen iterations of that in some form or fashion for, I would say, at least a couple decades, where something has been called artificially intelligent. Machine learning. That's where things get interesting. This is where a lot of the research has developed and changed and progressed rapidly in the last few years. So machine learning is best described as empowering a computer with the ability to learn. So it's no longer telling a system if X then Y, or if X then not Y, etc., etc. It's letting that system figure it out for itself. That's what machine learning is at the most simple level. If you want to liken it to humanity and humans, a baby is born without any knowledge, let's say, ignoring the whole nurture and nature thing. A baby is born with no knowledge, and if it doesn't have the ability to learn, then it will never grow up to be a functional, mature adult. It takes an ability to learn for a baby to grow and develop and become something bigger and better than what it is when it started. So deep learning. This is where things get really interesting and very, very cool. So first, let's start out with deep learning. So we've got AI at the top, machine learning underneath, and the bottom layer, the piece that's nested under machine learning, is deep learning. And this is where all the magic happens in AI. This is the pinnacle right now of what AI should be. So what is it? Deep learning at its most basic is a model inspired by the functionality of neurons to mimic a neural network. So first, what is a neural network? I've never heard that term before. Well, a neural network is most easily described as what happens in your brain. Your brain is a neural network. Neurons fire off in your brain and allow you to do really cool things like be rational or extrapolate or make connections or learn. The simple act of learning is an act of a neural network in your head. You can deduce things, you can think about something, you can analyze something from different perspectives, and so much more. And that is what deep learning seeks to accomplish. Researchers every day and developers, researchers and developers are kind of the same and kind of different in the AI space, because a researcher might come up with a new model, a developer has to take that model and actually implement it in some programming language to make it into something tangible, something that we could actually use, you and I. So I'm not going to say they're synonymous, because they're not, but they're not always different from each other. So deep learning's obviously better, right? I mean, we don't have to think about that for 1 second. Deep learning allows me to take what I've learned, or allows me to learn and to apply rational thoughts, make connections, deduce, extrapolate, all that kind of stuff that a human being would do, that machine learning just can't do on its own. But there's a cost to deep learning, and that is, how do you think a computer model is able to do all that? Well, with machine learning, you don't have to put in as much data for it to give it a foundation to start. With deep learning, though, you have to feed it tons of data, crap tons of data. It's kind of interesting. You could go off on a tangent here, and for 30 seconds I will. If you want to start thinking about the impact of our technological society and how AI is going to learn and grow in society, look no further than social media. We all dump our lives online now through Facebook, Instagram, Snapchat, Twitter, the original MySpace. We're providing an online repository that's endless of information for machines to learn from us. If that's not enough, look at hard drives. 20 years ago, a terabyte was a pipe dream. Today, 16 terabytes on a single 3.5-inch hard drive, and we're packing them into servers, home computers, anywhere a hard drive fits to be able to store data. You want to go even further? Our cell phones are connecting us and making us dependent on technology. AI is already in our lives, and our path forward, our future, is already predetermined when it comes to this. But it's just a theory. So why do you care about all this today? I mean, don't you need a $100,000 supercomputer to be able to run any of these models on? No. The reality is that a few years ago, NVIDIA launched their CUDA architecture, and, well, more than a few, many years ago, and more recently, we've discovered that we can offload a lot of AI functionality into the GPU, benefiting from the extreme amount of processing power that a GPU possesses in this day and age. For the cost of a $300 to $800 GPU, and if you get real serious and go with a Quadro or something, then up to $4,000 maybe, you can do some serious AI work at home. But that's still a lot of money to invest if you want to just play around with it and you don't have an NVIDIA GPU, or you don't want to mess around with your home computer or your gaming system. What else are your options? NVIDIA has you covered. They have a line of products called the Jetsons. Exactly. Small reference there to the TV show The Jetsons, which was set in the future back in the 60s. This year, they released the Jetson Nano. And that's what we have here today. The Jetson Nano is a tiny little computer, and I mean tiny. Let's just pull this out of the box here for a second. There it is. It sits on my hand. It fits in the palm of my hand. That's how tiny it is. Comes with a beefy heatsink on it. Looks beautiful. The Jetson Nano comes with an A57 quad-core CPU, 4 gigs of onboard memory, we've got HDMI, DisplayPort, 4 USB 3 ports, gigabit Ethernet, a micro USB port for power, or you could go for an optional bigger power supply, then you've got a 5 volts, 4 amp connector as well. Under the heatsink, under that PCB, we've got a micro SD card, there's an M.2, and the piece de resistance, the beauty of this board that puts it ahead of a Raspberry Pi, is what's under the heatsink. And that is 128 Maxwell CUDA cores. But all that is a package that'll cost $99 US. A fraction of the cost of a GPU, giving you all the potential to develop on this without all the cost. If you want to take the functionality a bit further, if you're going to run this 24/7 or something, you might want to invest in a 40mm fan. I say 40 millimeters because there are actual screw holes on the top of the heatsink that will align to a 40mm fan, so you can actually screw it on and not have to worry. There is a 4-pin fan header on the PCB as well. On the side, we've got a ZIF connector for a camera module. We've got some pins for power and reset. We've got a whole pin out on the other side of the PCB to allow you to attach accessories or develop and build further out. Other than that, it's pretty self-contained. The box itself, though, NVIDIA has given some thought to. So inside, you've got a little white fold out that you can fold up. You punch it down like this, put it in there. You now have a stand for your Jetson Nano. Beautiful. Ingenious thinking, way to use the packaging NVIDIA and not just make it another piece of garbage that I toss in the trash can after I've unboxed it. I love the use of that. The Jetson Nano, what can you do with it? Pretty much anything. You can use the tensor language. It works well with the CUDA cores. You can do video transcoding. You can encode or decode 4K 30 FPS streams. The possibilities are endless. So let's get started. So what do you need to get started? You need the Jetson Nano. I highly recommend a fan. If you want to do anything that requires a camera, like a live video feed or something like that, you're going to need a camera module. You're going to need a micro SD card to store the OS on and whatever data that you want to process with your AI model. I mean, it's got networking capabilities. You can use network storage if you'd like. If you're looking to use local storage though, you're going to need a high-speed micro SD card, and I would recommend a minimum 32 gigabytes of storage. And then last but not least, you're going to need a power supply. So by default, you can use a micro USB power supply as long as it supplies 2 amps of power. If you think you're going to need additional power, then you might want to shell out for the extra bigger power supply and get a 4 amp power supply, 5 volts, it'll plug in there. The caveat being that you do have to short out a jumper on the motherboard here to be able to accept power from that connector. So when you boot up, you're greeted with a very NVIDIA background experience. It's a very simple environment. It's Linux-based, Ubuntu specifically. You get Chromium web browser in there, a link to Jetson Developer Zone and the Jetson support forums. We've gone ahead and developed a very simple doorbell, door cam style application that shows real-time video analysis and facial recognition. So let's just pull that up here and we'll show you the power of the Jetson Nano right off the bat. So it's just a Python script. It's going to load up a facial database that's compiling all of the faces that the system has seen. And we're just getting a low frame rate video window here. You can see the camera in the background there. Now if I point my face at it, it does detect me. Because I was testing this out before the video recording, you can see it's active for 245 seconds there. It knows my face. It knows it's seen me 3 different times on 3 different occasions, which is kind of cool. It's not smart enough to notice that if I hold the smartphone in front of the camera, but it's still good. And this is real-time analysis of the video, so I'm just holding the camera here to make sure that it points on my face. You can see up here, it says known faces backed up to disk. So it's just backing it up into a file. Worth noting that the fan that we mounted on our heatsink just powered on. It's not running very quickly, but it's hot enough to justify. That's one of the very easy applications to put together. Like I said, it took us about an hour to develop this completely. And yeah, it's running very nicely and smoothly. We've been developing an application, an AI deep learning application to do object analysis and stuff like that for our photo library locally. It's not quite there, not quite ready to demo. Again, it's an Ubuntu build. It's very simple. I don't even need to use a mouse, but I can if I want. Shut down, bam. So there's our beast, our machine, our AI computer. It's not bad for $99 and I love it. I highly recommend anyone out there who's looking to do some AI development, dip their toes in it, and sorry, I say AI, but some machine learning, deep learning stuff. This is the box for you. If you plan to do anything and you're not looking to make a major investment, the Jetson Nano from NVIDIA at the $99 price point just can't be beat. NVIDIA really thought this one through. Once you've developed on this, if it's not enough, you can always step up to a better Jetson, the Jetson TX2, for example, which packs 256 Pascal cores, I believe. And you can get it with up to 8 gigabytes of RAM instead of the 4 gigs that the Nano has. But if you're looking to dip your toes, the Nano is the way to go. For anyone looking for more information on AI, I'll include some links below. And thank you very much for joining us today. It's been a pleasure working with this device, and I cannot wait to bring you our next program on the Jetson Nano, which hopefully will be soon. Have a great day. Thanks for watching today's video. If you didn't like it, you know what to do. Give us a thumbs down. Leave us a comment below letting us know what we can improve for next time. But if you did like it, give us a thumbs up. Hit the subscribe button. Don't forget to hit the bell beside it so that you get notified the next time we post a video. Don't forget to follow us on social media. We're on Twitter, Facebook, and LinkedIn. Have a great day, and we'll see you all next time.